Yeah, I've started recording. Don't worry, all the details related to the exam I will send out by mail. So the important point to remember here is that it's not the final answers which we are interested to evaluate. We will basically see your approach. So make sure that you write whatever you are thinking or whatever, however you are planning to solve the problem, you write those properly in that paper so that I can evaluate on the basis of that. Okay, and regarding the yeah,
Question.
so like regarding the practice problem, I guess I have already sent you some practice problems. We will discuss these briefly. So so maybe I can discuss the problems today itself. So let's take a look at those practice problems.
So we'll be getting some time for the scanning and the uploading part, right?
Yeah, you'll get time. Okay, so you can see the screen.
Yes,
You
Yes,
sir.
sir.
Yeah, so these are some of the practice problems which I shared with you earlier. I guess you have gone through it. So let's discuss the problems one by one. So anyone wants to volunteer how we will solve the first problem? By the way, regarding
Yes, sir.
Manhattan distance, I guess all of you know. So Manhattan distance is defined as follows. So suppose you have two vectors like this. Say this is V1 and this is V2. Both are d-dimensional vectors. Right? So Manhattan distance is defined as follows. So Manhattan distance is that, so there are d dimensions. You consider each dimension one by one. Small d is any one dimension out of capital D, and so you basically take the difference between the that particular dimension in both the vectors, and you take the absolute value of that difference, and then you take the summation of this quantity over all the data points. So the reason why, so like if you want to evaluate or understand it graphically, so let's consider a two-dimensional plane once again. Let the two features be called x, or the two dimensions be called x1 and x2 as usual. So this is one particular point for which this is, let's say, x11, and this one is x12, and this is our second point. Here this time the first dimension is x21 and the second dimension is x22, right? So the Euclidean distance between these 2 points is nothing but the length of the line connecting these two things, right? This is the Euclidean distance, or the straight line distance, or the Euc distance. Now, if you consider the Manhattan distance, it's basically what is the distance which you have to travel if you have to move in an axis parallel way. That is, from here to here, you can either go directly along the inclined path, or you may choose to go just parallel to the x-axis from here to here, and then along parallel to the y-axis or the x2 axis from here to here. So if you are if you are inclined to move from here to here and then here to here, like that is horizontally and then vertically, then the distance which you get is the Manhattan distance. Right, so this is inspired by the structure of houses in the city, like in the Manhattan region, where there are only all the roads are either horizontal or vertical. So if you are to move from a house here to a house here, you cannot just take a shortcut from here to here. Rather, you will have to walk along these either these horizontal roads or along these vertical roads. So that is basically the definition of Manhattan distance. So you can understand that the Manhattan distance between any 2 points is always going to be greater than the corresponding Euclidean distance. Okay, now let us come to the problem which is discussed here. Yeah, someone was volunteering to solve this problem, so tell us.
Yes, sir. Sir, what I did was I found out the distance of both the points 11 and 12 with respect to each of the points
Correct.
with ID 1 to 10, and then arrange them in ascending order.
Okay.
And the first point of difference for point 11 came in when k was equal to 2, and subsequently the y label for point 11 came as 1, and the first point of difference for point 12 came when k was equal to 1, and the y label came as 2. Is it correct, sir?
Yeah, fine. Approach is definitely fine. So as you like, so the way to solve it, as you said, is first so these 2 points, 11 and 12, these are the test points to be specified. So we will treat them separately. First, let us focus on the 11 point number 11. So we take this. So its features are -1, 0. So we calculate the Manhattan distance from this point to each of the 10 points one by one. So let us remember we are considering the Manhattan distance. So this one is -1, -1. This one is -1, 0. So what's the Manhattan distance?
1.
1. So these two are equal, so their difference is 0. Here the difference between these two is 1. I add them up, 0 plus 1 equal to 1, so that this distance is 1. So let's write down here, say point number 11 I am doing. So let me write down the difference distance to all the points, 1, 2, 3, 4, 5, and so on. So for 1, the Manhattan distance has come to be 1. Next, we move on to second point. So here, what is the Manhattan distance?
2.
So -1, again difference 0, 2, 0, difference 2. I add them up, 2 plus 0 is equal to 2. So here I write, here the distance is 2. Third point, -1, 4. So like you can see easily, difference distance in this case is 4. 4, right? And we also need to keep noticing the labels of the points. So 2, 1, 1, 1, 1, 2. So just write this. The corresponding y level is 2, 1, 1, 1, 1, 2, etc. Fourth, like similarly for fourth point, again you can see what's the difference. What's the Manhattan distance in this case?
4. Oh, no,
Hmm?
sir. 2, sir.
2.
2, sir.
So 0 to -1, difference is 1. -1 to 0, difference is also 1. So 1 plus 1, 2. So difference 2, so distance to level is again 1. Similarly, for point number 5, again it's 1. So, and the level is also 1. So we write it's 1 and 1, etc. and so on. So you can like complete the thing together. So now let us, once I have got all the distances, and so let us just pretend that the other points do not exist. I mean, of course they do, so you'll have to calculate them, but for the sake of time, I am not going into doing it for all the points. So these distances, if I sort, I will first have at the distance, I will have 1 and 5, both of which are at a distance of 1. Then I have 2 and 4, both of which are at a distance of 2. And then I have 3, which is at a distance of 4. And the labels here are 2, 1. For 2, it's 1. For 4, it's also 1. For 3, again, it is 1. Right? So if I consider k equal to 1, so there, like the first nearest neighbor is of course these 2 points jointly. So as I have written here, like if there are multiple neighbors at equal distance, consider all of them. So for k equal to 1, although I say k equal to 1, there is one nearest neighbor, I am forced to take both of these 2 points because they are at the same distance. And I find that one of them is 2, one of them is 1. So at this point, I cannot like take any decision. So let me just count the votes which they have, the two classes have got. This has got one vote, this has got also got one vote. Okay, then what the question is saying, but saying that increase k till there are no ties. So now what I do, I go for k equal to 2. K equal to 2. So these two, so now I have to consider these 2 points, right? 2 and 4, which are at the equal distance. So now what do I say? I see that both of them are saying 1. So the class 1 gets 2 more votes. So class 1 has 3 votes, class 2 has only 1 vote. So now there is the tie is resolved. So I stop and declare the class level of point 11 as 1. The same thing I do separately for class 2, for the 12th data point. I keep on calculating its Manhattan distance to all the points and then just take the vote as soon as I am able to, I see that there is no further tie. Okay. So assume that all the neighbors have equal weightage. So yeah, so that is when the weights of these 2 points, they have equal weightage of the votes of these 2 points. So I just get 3 votes for class 1 and 1 vote for class 2. That's the first problem. In case of the second problem, it's more or less the same, but the main difference is that here.
Excuse me, sir.
Yeah.
So I had a doubt.
Yeah.
Like in the first question, like there was the first tie at k is equals to 2, right?
Yes.
So
At k equal to 1, there was a tie.
oh yes, sir, sorry. K is equals to 1, there was a tie. So like there will be another 2 ties after that, like for after some gap. So we don't have to consider them.
See, the question is saying increase k till there are no ties. So at k you started at k equal to 1 and you found a tie. Then you moved to k equal to 2 and there was no tie. It's 3-1. It became 3-1. So then you stopped.
Okay, sir. Like when I did the question, I found all of the possible like to the value, k value 10, and there were ties. There were 2 consecutive ties after like k is equals to 2. Like at I guess k is equals 6 and 7.
That's fine. But the question
Sir,
says that starting
you're taking k is a distance, right, sir?
that is I am taking, that is I am using this policy that if there are multiple neighbors at equal distance, consider all of them. So in a normal situation, in case of k nearest neighbor, I should, by k equal to 1, I will mean only one neighbor. But there are 2 neighbors which are at equal distance. So in that case, I am forced to consider both of them. If I, instead of Manhattan distance, if I went for Euclidean distance, because there is square root and everything involved, probably I would be instead of integers, I would probably be dealing with real numbers. In that case, this situation of having multiple points or having multiple neighbors at equal distance, I'll probably be able to do away with. But in this case, I am getting because I am dealing with integers. I am finding multiple points at exactly equal distance. So I am being forced to consider both of them together. Again, this is not a hard and fast rule, and this is not the only way in which k nearest neighbor can be done. It's possible that in case of a different version is also possible, in which if I find 2 points or multiple points at equal distance, I choose randomly one of them. That is, maybe between all, I find that these 2 are at equal distance. That is, both of these are nearest neighbors. But I just randomly select any one of them, say this one, and I use it as a vote. So that also I can do, but in this case I am not doing it because it's written the question, if there are multiple neighbors at equal distance, consider one of them.
Sir?
Yes.
Sir, if in this question instead of Manhattan distance it was Euclidean distance, then you have to consider 10 points.
Then also we'll have to consider 10 points only, but the way we are calculating the distances, then it would have been different. So instead, for the first one or first one and point, the first 3 points, I think it would be the same because the difference between these two has become equal. But in some other points, for I think for the fourth point also the numerical value would come to be equal. Yeah, so like we will no, like here we will get 1 minus 0, that is 1 square plus 1 square, that is 2, and then the square root of that. So in this case, the Euclidean distance between these two would have become square root of 2, but the Manhattan distance remains as just 2. Right. So similarly, in some other cases, is like the Euclidean distance will be changed, and it will be it will be less than or equal to the Manhattan distance. But you will have to the approach will remain the same. That is, each of the point you will have to consider one by one
until there are no ties.
So, the question of tie comes later. That is, first of all, you will have to, the question of tie is when you are trying to classify it. But before classifying that, first you have to understand which are the nearest neighbors. So for that, you will have to measure the distance from the test point to all the training points and then sort them. That is something you will always have to do regardless of whether there are ties or not. So only after you have done the sorting, then you will find that whether there are some points at equal distance, and then that is one kind of tie. The other kind of tie will happen if there are if both the classes are getting equal number of votes. So that is when I am talking about ties here. By tie, I mean that that is both classes getting equal number of votes. But there is a different kind of tie also to be considered here. That is multiple neighbors at equal distance. And for that, I have given you that you have to consider both the neighbors equal, like at the same time. Yeah.
Or should we define distances every time? Is it necessary? Can't we just find once and evaluate k?
That is, you need to understand which is the nearest neighbor. So, to know which is the nearest neighbor, then that is like you have to evaluate all the same distances, right? Otherwise, how will you understand which is the nearest neighbor? It's possible that you calculate the distance from -1 from the 11th point to the first point, but it's possible that the nearest neighbor is the 9th point. So unless you calculate all the distances, you will not know which is the nearest neighbor. So that you will have to do. From that, there is no escape. But once you have calculated all the distances, then you will not have to recalculate them at any stage. For every point, you will have to do these same distance calculations and then sort them. And then based on that, after that, you keep on increasing the value of k. For that, you will not have to revise the distances. The distance computed for one point, you calculate the distance to all the points and then do the k based analysis.
So suppose we got the 2 points of the same distance and it's not stated that they both have the same weightage. So how would you define the weightage of the
Sorry, can you speak louder?
Sir, if it is not stated in a question that both the points have the equal weightage and it is happened that we found 2 points at equal distance, so which point shall we consider?
I could not hear, but what I understood is that you are asking that suppose this line was not written. If it was not written, if there are multiple neighbors at equal distance, consider all of them. Then you are saying that in other case, which point you should have chosen, right? So while you are implementing it in Python, then of course you will write a random number generator. That is, out of the you will collect the list of the points which are at the same distance, and out of them you will randomly choose one of them. Now, when you are doing it in paper, of course, you cannot randomly choose it. So like you can just that is you just choose any point, any of those points which you want, and just write it down. So just like in the for the purpose of the exam, like as long as you are you write down your assumptions correctly and clearly, there is no problem. You can choose any of the points you want to. Of course, the results will change depending on which point you are choosing. That is to say, if instead, in this case itself, if you randomly select this point number 1, then your predicted level will be 2, and if you randomly choose this one, then your predicted level will be 1. So the result will be different, but as I said, it's not really the results which we are going to see, it's your approach which we will see. So as long as you clearly write what you are doing, there is no issue. Now coming to the second problem is just a spin-off from the first problem. It is just saying that instead of set the weightage of each neighbor as reciprocal of the distance from the query point. So in this case, so the distance from the query point we have calculated to be 1, so its reciprocal will be 1. Here also that is 1, so its reciprocal will be 1. Here the Manhattan distance is 2, so its reciprocal is half, which will be the weight of this point. Similarly, in this case also, the weight is going to be the reciprocal of 2, which is half. In this case, the reciprocal is 1/4, etc. So now the only difference is when we are counting the votes. So when I count the votes, we are first looking at point number 1. Right? Point number 1 is giving the class level of 2. So for 2, I get 1 vote. Okay, 1. Next, I consider the second point, which has got that also has got 1 vote. So I can write 1 class. Next, I consider these 2 points together, point number 2 and 4. So point number 2 is voting for class 1 and its weight is half. Similarly, point number 4 is also voting for class 1, is equal weightage half. So now what is my scoreboard? My scoreboard is now 1, 2. So class 1 has now got 1 plus half equal to 2 votes. Class 2 has got only 1 vote here. So already the tie is already resolved. Class 1 has got 2 weighted votes. Class 2 has got 1 weighted vote. So like I say that y equal to class 1. Similarly, for the other data point also, I will do the same thing. So that is just a spin-off from this problem. Okay? Like
Sir,
on
answer is C and B.
sorry.
Answer for the second question is C and B, right?
What is C and B?
They are the class labels in question number 2.
Sorry. One. Sorry. Yeah. Sorry. I didn't see that. So like what I meant is that it's like if you just do the for the first data set, in the first question itself, if you apply the this weighting criteria, then yes, then it will be like that. So let's do it for the second data set also. Let's do this.
More or less similar.
Yeah.
Can you just tell the answer?
Sorry.
The approach is clear. Like the way you explained, taking example of 1 only. I was asking just about the answer only.
Okay, fine. Yeah, the answer is clear. Now let's come to the decision tree. Okay, so here you have got how many? Like you have got 10 points, and each of them are 2-dimensional. So that is and basically what you have to do is you have to build a decision sum. And so as you can see, it's a binary classification problem only, because y takes only 2 levels, A and B. But the features x1 and x2, they take it seems they take real numbers. that is they take values like 2.5, 1.5, etc., etc. So that means I will have to choose a split, like I have to choose a threshold on which I may want to split this feature x1 or x2. That is, I have to decide two things: whether I should choose, that is, whether I should split on the basis of x1 or I should split on the basis of x2. And then, if so, then at which point I have to split. So this is a dilemma which I mentioned earlier also, that is how to choose the threshold for splitting, because we cannot choose all the, we cannot evaluate all the thresholds, especially if it is a real valued feature. So for your benefit in this case, these four options have been given to you. Either I'm not saying that any of these is the best possible split. I'm just saying that among these four splits, which one is best. Okay, so let us consider. So to understand that, first of all, let us plot the problems. Plot the data points on the axis. Okay, so let's do this. Like when you are faced with a decision tree kind of problem, especially if the if it is two-dimensional, then it often helps if you actually plot them on the 2D plane. That helps you to identify the feature. So whenever you are theoretically solving a problem related to decision tree, if possible, you can try to plot them like this. So x1 and x2 are the two features. So let us try to plot. Okay. So point number 1, x1 is 1 and x2 is 5. So let us say it will be a point something like this. This is 1 and maybe here is 5. So here I put this point, and since its label is A, I put AI here. Okay. Second point, 6, 5. So here maybe this is 6. And here is 5 again. So I put here, and here the class label is B. So I just write B here. Third point, 2, 4. So here is 2. And here is 4. So 2, 4, and the label is A. So I have A, write A here. Fourth point, 6, 4. Here is 6, here is 4, and label is B. Fine. Fifth point, 1, 2.5. So here is 1, here is, so let's calibrate here. 1, 2, 3. Please waiting in the lobby, just a second. The fifth point is 1, 2.5. So it is somewhere here, and its label is B. So I write B here. Sixth point is saying 8, 2.5. So here is 8, and here is 2.5 again, and the label is A. Next, the seventh point is 5, 2. Here is 5, here is 2, and the label is A. Eighth point, 3, 1.5. Here is 3, and here is 1.5, and label is B. So I write B here. Ninth point, 1, 1. It's here, and its label is B. 10th point is 6, 0. Point here, and it's on the axis itself. So, and its label is A. Fine. So now, so this is what my point looks like. So now what is being asked is that, so which of these points I will choose, or which of these criteria I will choose for splitting. x1 greater than, say let us consider first one, x1 greater than 4. So this is x1 equal to 4. So if I draw a line here, I am drawing this line here. What is this line? This line is basically the line called x1 equal to 4. Everything on this side is x1 greater than 4. Everything on this side is x1 less than 4. Now, if I look at the so let us say x1 greater than 4. This is my splitting criteria. On this side are all the points which satisfy the criteria, that is x1 is greater than 4, that is all these points, and here I have all the points which do not satisfy the criteria, that is these points. So if I look at these points, what is the class distribution? I see 3A and 2B. Here if I see on this side, I see there is 2A and 3B. So if a node comes here to this side, so in this leaf node, so what I have to do according to decision tree algorithm, I have to choose the modal label. In this leaf, what is the modal label?
A.
If there are 3A and 2B, A is the modal level, and in this case,
B.
In this case, it's B. So now, if this is the decision tree I construct, then what's the accuracy I will get on the training set?
60%.
These three will be correctly classified, these three will be correctly classified, so I will get 60% accuracy. Okay. Now let's, so I'm at this point, I am not saying whether that is good or bad, because we have to evaluate other options also. So what about if I go for x1 greater than 5.5? Say x1 greater than 5.5. So pardon the bad drawing, y and n. So 5.5 means this line, right? So now which are the points I am getting on which satisfy x1 greater than 5.5? Now these 4 points. So here I am getting 2A, 2B. Okay. And on this side I am getting 3A, 3B. Okay. So in neither of the cases there is any modal level. So what I have to do is I have to randomly choose. See, both of them have equal frequency. I randomly choose one. Let's say in this case I get B, and again here also I have equal frequency. I again choose one of them randomly, and let's say in this case also I get B. Okay, so that means whatever is the case, I am going to end up predicting B. What is my accuracy?
50%.
50% accuracy. If instead of choosing B and B here, if I had chosen A and A here, then what would have my accuracy have been?
Same, so 50%.
Still 50%. If I had chosen A here and B here, then my accuracy?
Same.
Then also 50%. So basically, like when I'm when I encounter this kind of situation, so like which level I choose in these cases basically does not matter. I always end up getting equal accuracy, which is 50%, and that is definitely so basically this means that this has become like a random classifier. So it is definitely worse than the first one, which gave me 60% accuracy. So B is definitely not an answer. So we throw this away.
Sir, do we have to consider F1 score also?
Sorry, if the score, yeah. So in this case, because the two classes are like are in equal proportion, and no class has been told to you as a target class, so we will not usually go for a precision recall. So we can just go for the plain simple accuracy. But in this case that works, because that makes sense, because like there is no target class is mentioned and both classes have equal frequency. But yes, if a target class is mentioned, which may be mentioned in some of your exam questions, in that case, yes, in that case you have to go for precision, recall, F-score and everything. But in this case, you can go for plain simple accuracy. Now you consider the choice C, which is x2 greater than C. So what is x2? x2, so x2 greater equal to 3. This is the line, horizontal line, x2 equal to 3. Everything above it is x2 greater than 3. Everything below it is x2 less than 3. So x2 greater than 3, y n. So
the line is y equals x2 equals 2.
Sorry, sorry. That line has become x equal to 3, not 3. So this one is the correct one. x2 equal to 3. Okay, so this one is which one? This one is at this one is at 2.5, I guess. So this one is slightly below the line on this side. Okay. So now, if I look at all the points satisfying x2 greater than 3, well, like these 4 points satisfy x2 greater than 3. So what's the class distribution? Once again, I have 2a, 2b. Here also I have 3a, 3b. Right, so this case becomes just same as the x1 greater than 5.5 case. So here also I will get 50% accuracy. So here this also I can ignore. This is also not a right choice. So next we consider x2 greater than 0.5. That basically leaves us what? x2 greater than 0.5 means everything which is x2 equal to 0.5. So that means basically all the 9 points on this side will be belong to one class, and everything like this, only 1 point will be the other one. So x2 greater than 0.5, here y and n. So here if it is n, then there is only 1 point which satisfies a, 1a, 0b. And on this side it is like 4a and 5b. Okay. So here, so in this case, the modal level is b. In this case, modal level is a. So what's the accuracy I get in this case?
60%.
This case, so I get 60% accuracy. Yeah, so just like the first one, in the first one I got 60% accuracy. In the last one also I am getting 60% accuracy. So then can I say that both of these are equivalent and I can choose either of them, or I have a preference? I will have a preference also between these.
So
Sir,
first
I
one is
didn't understand why is it
X1 is
60% in the last case.
Sorry, one at a time.
Sir,
First one,
I didn't understand why is it 60% in the last case.
this was the here 1A is correctly classified. Here 5 B's are correctly classified. So 5 plus 1 equal to 6.
Okay,
Right?
sir. Okay, sir.
So in this case, between the first and the last, which will I prefer, or will I
the first one.
why first one?
So because in the last one, the sample size is very small, like there's only one A and zero B in that, x2 greater than 5.
Exactly. Like this is something we discussed earlier during the lecture. I want balanced nodes. I do not want nodes which are which contain which are supported by very small number of examples. Like if we had actually gone for the information gain, if we had actually calculated the information gain instead of calculating the accuracy, you would have found that the information gain is higher in this case instead of in this case. Right? So that is you note that in this case I have not explicitly told you on what basis I should be taking this decision. That is, should information that is I was making the decisions on the basis of accuracy. But apart from that, there is the information gain also. That is, I had told you in class that the splitting has to be on the basis of information gain. I have not calculated the information gain, but if you calculate the information gain, probably you will find that the A has the higher information gain compared to the last one, even though they both have the same accuracy. So in that case, your answer is going to be A. Okay. The second problem is this one.
Sir, can you explain the A part? You've taken A as the answer, right?
See, if you calculate the information gain for the 4 defined slips, then you would have gotten A as the one giving you maximum information gain. I did not calculate it, but I leave it. But you should calculate. But intuitively also, if I consider only the accuracy, A and B, both of them are giving you equal accuracy of 60%. But something which we discussed in the lectures is that I do not want small leaf nodes having small number of levels. I want the leaf nodes to be more or less balanced. In this case, that is both the leaf nodes are having 5 training examples each. Here one has 9, the other one has 1. So this is becoming a very small leaf node. I don't want that. So that's why qualitative, without going into information gain criteria also, qualitatively I will prefer this one rather than this one. If you have any further doubt,
so can we do we have to calculate the information in the information gain in the test?
If it is explained or if it is specified in the question, then you should do it. If not, then whatever criteria you are using, just write down that and that should be it. If there are any further questions, please send by email because we have to wrap up in another 5 minutes. So let me go to the next question, which is related to decision tree regression. So this question is saying that here there are 8 data points with 3 attributes. So note that the attributes are binary in this case. So it will be simpler. So and you have to go for a regression stump also. So let's make it like as easy as possible. Just a second, let's see. Arrange this properly. So let us say I am going for let us say let's say I am going for x1. Okay. In case of x1, there are 2 values, 1 and 2. If I let me draw it in this way, in the usual way, x1, so it takes 1 and here it takes the other value 2. So if you consider all the values that are in under x1 equal to 1 and all the values that are in x1 equal to 2, so what are the different values? X1 equal to 1 has the different values of y are 3, 10, 4 and 12. Am I right? In case of the these values, in case of x1 equal to 2, you have 3 training points, 5, 6 and 7, for whom the y values are 2, 9 and 2. 2, 9, 2. So I leave it as an exercise for you to calculate the standard deviation in this case So like you know how to do it, right? So first of all, if I calculate the mean of these values, so what is the mean? 7 plus 10, 17, 29. 29 by 4, mean is equal to 7.25. In this case, what's the mean? The mean is 13 by 3, which is 4.33. Right? And the standard deviation, you know how to calculate it. Mean of squares minus square of mean. So you calculate 1/4 of p square plus n square plus 4 square plus 12 square minus 7.25 whole square. That's this is basically the variance. And it's the variance which you need, not the standard deviation. So variance is something which you will get in this case. In this case also variance you will get, that is 2 minus 4.33 square plus 9 minus 4.33 square plus 2 minus 4.33 square. So some value you will get. So that will give you the split one, the split fraction times split one variance plus the split fraction 2 times split 2 variance whole negative. So what is this fraction? So the split fraction is 4 by 7, and this split fraction is 3 by 7. Right? So whatever value, so let me call this variance as V1. Let me call this variance as V2. So I calculate minus original there is, apart from that, there is the original variance also. So what is the original variance? Let's call it as V, which you can just calculate. So the gain, the variance gain which I get in this case is V minus 4/7 of V1 minus 3/7 of V2. Correct? And so this is the variance gain which you get in case of feature number x1. Now similarly, if you go for feature number x2, there also you will see something similar happening. So x2 is also a binary feature that takes only two values, 1 and 2. So if you look at those which are which satisfy x2 equal to 1, you will get, what are the y values? Tell me the y values. Quick.
1, 2, 5 and 6.
Tell me the y values.
3, 10.
3, 10,
2 and 9.
2 and 9.
9.
What about here?
4, 12.
4,
4,
12,
12, 2.
2.
4, 12, 2. That's all. So now again, so here you can again calculate the mean. Here also you can calculate the mean. So you can get the variance, which let's call it as V3. Here also you'll get the variance, which I call as V4. So the variance gain in this case is going to be V minus. So note that their split sizes are again 4/7 and 3/7. Right? So I will get V minus 4/7 of V3 minus 3/7 of V4. So some value, so you'll get some numerical value of it. And then similarly, the same exercise you can try out for the last one also, which is x3 is equal to that is you can split on the basis of x3. That is x3 you can go for either 1 or x3 is equal to 2. So in that way also you will get some sorry, not like this. So x3 is equal to 1, x3 is equal to 2, and there also you will get a set of points which I am not mentioning. You can calculate it, and this way here you will get V5, you will get V6. So again you will have to carry out the calculation, say V minus 4/7 of V5 minus 3/7 of V6. So out of these three quantities which you get, whichever is the highest, you choose that one. So I am not calculating those, so that I leave it as an exercise for you to do. So suppose it turns out that this one is the highest. So then your decision is that this is the decision tree along with, this is the regression sum which you are going to choose. That is, you will choose x1, 1 and 2. So and if it is x1 is equal to 1, then your prediction will be the mean of these levels, and if x1 is equal to 2, then your prediction will be the mean of these levels. Right? Let me call it as mu1 and mu2. So now what am I going to do? I am going to classify the test point, which is the 8th point. So here I look at it, since x1 is the criteria, I look at its x1 feature, which is 2. So I come here and I predict its value, its y value to be 4.33. So this is my prediction here. I predict here that y is equal to y of 8 is equal to 4.33. This is my prediction. Fine. Okay. So in this case, not able to hear what you are saying. So, like in general, in this case, like you may have observed that in all the three cases, like on all the cases, the split sizes are 4/7 and 3/7. But this is of course not, that is because of the peculiar characteristics of this data set, this did not happen. So it's possible that this one will be 4/7, 3/7, this one will be 5/7 and 3/7, this one will be 3/7 and 4/7. Something like that can happen. So you have to take care of all those things. Okay, so but this is like basically this is the approach in which you can solve this decision tree regression problem. Okay, so that's the end of
So
this
in
class.
this regression stump, we want variance to be as low as possible, right?
Yes, you compared to what you got, like compared to the original variance. So that is why you like you calculate the difference, that is the reduction in variance from the original variance to, from the original set to the subset. Which wherever this reduction in variance is maximum, that means you are getting like that split is giving you the least variance. So it is the
Okay.
okay. If there are any further questions, please drop me a mail. Meanwhile, we have come to the end of today's class. So tomorrow we will discuss regression, and on Wednesday, as I said, your assignment submissions deadline is extended till next Wednesday, and on Wednesday from 3 to 4 we will have the test. The question that you will be given a link to a Google Drive where your question paper will be stored. You have to choose the question paper which is for your roll number. You will have to answer it on a paper, scan that answer and upload it in a link which I will share with you. Don't worry, I will repeat all these instructions in a mail. Okay? And during the test, if you have any questions, please don't ask it aloud. Please just drop me drop me a text message on the MS Teams.
Excuse me, sir.
Yeah.
Sir, can you send the solution of that exercise so that